Hello student, today we are going to perform experiment on CRO, that is cathode ray oscilloscope. So cathode ray oscilloscope is an instrument which convert an electrical signal to a visual signal. We can visualize a signal, an electrical signal on the screen. The heart of this instrument is a CRT, that is cathode ray tube. It is same as picture tube of an ancient TV. Okay, here electron gun is there which emits electron, then some control grid which are connected to the knob of this CRO that I will tell one by one, and finally the electrons are striking on the screen. Back side of the screen there are some phosphoric coating. When electrons strike on it, then some visual points come, so we can follow or we can see a signal. Now just say that is an electron beam, or we can say it is a light. Now we are connecting a function generator, another instrument. It is a function generator which can generate various type of function. So sinusoidal function you can follow in CRO. The sinusoidal function is coming from here. If we press this one, the waveform is now rectangular. If we press again, it will be triangular. So this function is generated by this one. So it is called function generator or signal generator. And this signal we can obtain or we can see in CRO. Okay. Now this is an electrical signal. So some parameter we have to measure with CRO, because CRO is a measuring instrument. The first thing we will measure the voltage. What is the voltage? Voltage is called here amplitude. Amplitude means from here to here. So how to measure this? You just follow. This is a dual channel CRO. Dual channel CRO means there are two separate channels. It is channel 1, another one is channel 2. So now our signal is connected to channel 1. So vertical movement of the signal we can shift by this one. So now we are setting our lower level to one of the axis, and we will measure the total length. You just follow. It is how much? It is 1, 2, 3, 4, 4.8 division. 4.8 is the division, and time per division is channel 1.5. So what is the voltage? I am saying you. So it is volt per division. So volt per division is in 0.5 volt, and total length or the amplitude is 4.8 division. So what does it means? 0.5 volt per division. That means one division equal to 0.5 volt. Then what about 4.8 division? It will be 4.8 into 0.5, that is 2.4 volt. So in this way we can measure our voltage from CRO. Now if our voltage changes, how to change your voltage? In function generator, one knob is there, that is called amplitude. By changing this amplitude, we can change our voltage. Just to follow. Now it is very high amplitude. Now it is very low amplitude. So we can set our amplitude from here. And if it is very high, then how to measure this? We have to change our scale. We can change our scale in 1 volt per division, or we can even change it 2 volt per division. Then what about the reading now? That will be multiplied by 2 volt. Then the exact reading we will get. If it is very low, so how to change our amplitude? Again from function generator. Okay. The function generator say it is very low. So it is very difficult to measure now from CRO. So what to do? We will change our volt per division knob in the lower scale. Say here it is 0.2 volt. It is 0.2 volt, and how much it is? It is 1, 2, 3, 4 point something. So 4 point something into 0.2 volt. In this way we can measure a amplitude. Now we will measure frequency of that signal. So directly we cannot measure frequency from here, but we can measure the time period, and we know that F equal to 1 by T. So frequency is a reciprocal of time period. So how to measure time period? You just follow. A complete cycle is from here to here, or we can say from here to here. Now by this horizontal shift, we can shift our signal anywhere horizontally, that is left right, by this one X shift. And you just follow from here to here is how much division it is. From here it is 1, 2, 3, 4 and 4.2 division. So it is 4.2 division, and scale is here, time base is 0.5 millisecond. So 4.2. So the reading is 4.2 into 0.5 millisecond. That is the time period. Then what is the frequency? The reciprocal of that. and here it is millisecond, so frequency is in kilohertz ranges. So in this way we can measure our frequency also. Now say our frequency changes. So from where it will change? CRO will change nothing, because CRO is a measuring instrument. So who can change the frequency? Who have actually generated that frequency, that is a function generator. So we are now increasing our frequency. You just follow, you can follow both the screen also, and you see now the frequency is more or less 1 kilohertz or whatever is there. How to measure? You can measure from here to here, or say if it is very close or it is very difficult to measure from here. So what to do? For high frequency you will select a higher time per division scale. Now you can measure it is from here to here, 1, 2, 3, 4, 5, 6 division, and it is 0.1 millisecond. So if your frequency is low, you have to go a lower scale. If your frequency is very high, you have to go a higher scale. So any frequency or any amplitude you can measure from CRO. Now I want to say you something about the knobs of the CRO. You just follow. Signal is connected in channel 1. Now here it is written XY. XY means if we press this one, a vertical line, that is maximum to minimum amplitude we can measure from here, XY. Here it is written channel 1/2. When it is open, then it is showing channel 1. If it is pressed, then it is showing channel 2. Nothing is connected. If we connect in channel 2, then we can obtain our signal again. So that is the signal in channel 2. And when it is connected in channel 2, we have to vary this volt per division, and we will follow this reading, this green color. And when it was in channel 1, then we will vary this blue one and we will get the blue reading. Clear? Now the next part, it is a Lissajous figure. So what is Lissajous figure? When two separate signals are produced in X and Y, that means channel 1 and channel 2 of a CRO, then by superimposing of these two signal, we can obtain some figures in the screen. That is called Lissajous figure. So better we will get a Lissajous figure first. For this you have to press X, Y. You just see what is this? It is a circle. Actually, some Lissajous figures are here. You just follow the first line, it is a circle or an ellipse. Second line, it is more or less figure of 8. Then another figure. So these are the Lissajous figure. So from here, from Lissajous figure, we have to calculate an unknown frequency with reference to a known signal and a Lissajous figure. So for this, a formula is there. That is FV into TV equal to FH into TH. So what is FV, TV, what is FH, TH? I will tell you. This is our Lissajous figure, an ellipse. So it is x-axis, it is y-axis. So whatever frequency is connected in x-axis, that is called Fx. Whatever frequency connected in y-axis, that is called Fy or Fv, vertical frequency. And what is TH/TV? Nothing. In a Lissajous figure, we can draw tangents horizontally and vertically. So number of point touched in Lissajous figure, number of point touch, this tangent touch in Lissajous figure, that is called TH. That is how much? That is 1, only 1. Here also, number of point touch in vertical tangents, that is also 1. So here formula is Fv into TV equal to Fh. Just follow. This is the Lissajous figure. This is tangents parallel to x-axis, and that is tangent parallel to y-axis. So Fx is the horizontal frequency. Horizontal frequency actually you just follow. Channel 1 is written Y, channel 2 is written X. That means whatever frequency is given in channel 1, that is actually the vertical frequency. This one, vertical frequency is entering here. And channel 2 is written X, that is the horizontal frequency. That is actually our this instrument. So this frequency is Fx, this frequency is Fh. Now any one of these two may be a reference frequency, another should be unknown frequency. So say our reference frequency is Fh, that is this one. This one is reference frequency. We know that the frequency here. So what is this? It is 1 kilohertz. So Fh equal to 1 kilohertz. Then clearly Fv and Tv both are 1, 1. Sorry, TV and TH, both are 1. Then what about FB? FB equal to FH into 1 by 1, that is, it is also 1 kilohertz. So the FH, whichever was unknown up to this point, now it is known. You just follow, the both are 1 kilohertz. Okay, and when both frequencies will be equal, then only a circle or an ellipse may appear, because here 1 point, here also 1 point has cut. Okay, now we want to go, change our frequency. That means this is our reference frequency and we will change that frequency. So say we can make, and if you follow the Lissajous figure, we are changing our frequency, how much? Say it is only 500 hertz. Now just 500 hertz. You follow, horizontally how many points touched? 1, 2. Vertically how many points? It is 1. So it is 2:1 figure. And you follow both the frequencies. One is 1 kilohertz, another is 500 hertz. Clear? Now we are changing again our frequency. Now we are try to set it to 2 kilohertz. Now just follow. Here it is 2 kilohertz, here it is 1. So now this frequency is double. That frequency is double. So you just follow. Now horizontally only 1 point touch and vertically 2 points. So it is frequency 1:2. That means this is 1 kilohertz and here it is 2 kilohertz. So any frequency can be measured. Some more research figure I want to show you. 3. So it is 3:1 figure. Just follow. Here it is 3 kilohertz and here it is 1 kilohertz. And the figure also saying that horizontally 1 point touch and vertically is 1, 2 and 3. So it is 3 times frequencies. So using CRO, what we can do? We can measure amplitude of an unknown signal. We can measure the frequency of unknown signal, and by using Lissajous figure, we can compare two frequencies. One is reference, another unknown. So that's all.